Alright everyone, we're going to take a look at this particular outcome from a generative design and make some manual improvements to it using our mesh modeling approach. So to explain what you're looking at, this is a piece of work we've done from a previous project where we have been doing a monitor bracket. Let me give you a quick example. And the design, as you see, is that standard kind of like attach this to your desk, you get the swivel out, and it's got a bracket, a VESA bracket at the very top. And so what we're doing in this particular case is we're actually giving an extra extension. So if you think of it this way, what we're going to do is we're going to attach to this bracket, right now it's a horrible job, but we're going to attach to this part of the bracket, and then we're going to come up higher to actually connect into the monitor itself. So we're essentially raising it up a certain number of units to make it happen. Now the problem is when you actually have your monitor attached up here, you now have the weight of the monitor pushing down on these points, and especially if you kind of lean it forward a little bit, you're going to get like a little bit of a horizontal force as the monitor starts to go from here to here, and you're going to have the points of force goes from just like a straight up and down to more of an angle on the overall part. So we got to watch for that. Now in this particular design, what we've done is we have actually accounted for this. Actually, it's upside down right now, but this is the X brace or the X bracket that you saw in the picture. So this is where the monitor arm stops, and this extends up into the actual monitor. Now, obviously, the issue of potential failure is going to be right in here. This area where it's transitioning from basically the back side of the monitor and then to the inside of the monitor to go in and actually hit the connection points. That's why you have this block out zone here. So what we need to be concerned about is right here and there. Now, one of the tricks we're going to do is we're going to actually, what I call plastic welding, or just welding with mesh mixer or mesh mixer welding, and we're going to add more reinforcement right along this edge, and then we're going to turn around and come back here and add some ribs to get us a little bit of strengthening back on this side. So I have already actually converted it to a mesh, and so I'll need to get it into mesh mixer. I've done my outcomes within this, so let me go ahead and just take care of that real fast. And here we go. Now, you could do this type of work. I can get it to behave here. You could do this type of work in mesh mixer, or I'm sorry, in Fusion if you wanted to. You could actually do the manipulation and creation of the ridges and everything else if you want, but I find it much easier to do in mesh mixer or any other type of STL or like mesh manipulation file than doing it here. So I'm just going ahead and export this out. Just come right over to bodies here, save as a mesh, and tell it I can be an STL 3MF. I'm going to switch to an STL, and then tell it to export. And I opened up in Mesh Mixer, and you can see the file right here. Now we could go through the process of doing my turns and everything else to get it oriented right to the build plate. Not too worried about that right now at all. What I'm really worried about is actually doing the welding necessary to kind of get a little bit more reinforcement in these joints. And there's a lot of different ways you can do this. I prefer to use some sculpting tools, and so I'm going to do perhaps a knot. I can either do a draw or an inflate. I'm going to go with the draw. And I'm going to look at the size of my sphere that you see. It's a little bit large, so I'm going to dial that down, and then I'm going to try, maybe that's a little bit too much. But anyway, we're going to zoom in here, and I'm going to maybe increase the size a little bit. We're just going to try, well, a little bit down. So we're just going to try it. And as you can see, if you look in real close, you can see that it's filling in this gap. So I'm going to maybe increase the strength a little bit more, maybe decrease the size a little bit, and I'm going to just do a approach of a back and forth weave at this junction, just kind of like we do in welding. I'm going to take a look at it. See the creations that have occurred from this. I'm going to go back and forth over top a little bit, not too much. And also you'll notice as you actually like let it hold over certain areas, it'll keep filling in. So I'm just going to keep weaving back and forth. Maybe fill that zone in right there. Nice bead at that point. Nice bead at this point. I'm going to try to avoid getting too close to the edge because you start to warp the meshes in that case. And you can see that I've got some nice strong ridges in this case. So zoom out here, do it again. I like to zoom in nice and close. So start here, there we go. Weaving back and forth, probably slowly. And now you may ask, is this like a structural calculation kind of thing? And no, it's not. It's more intuition of where I just know stress is going to be. And even though I told Fusion to avoid this corner, it generated based on what I told it to do. But I also know that it doesn't ever hurt to come back and kind of use that knowledge to and kind of common sense, because if it's going to break at this joint. And any kind of sharp corners like it has there is sort of a bad thing. So filling that in, giving a little bit of, and the other point that I want to make here is that this sort of inconsistency in the way that I'm doing it, how it's not perfect and uniform, is actually to our benefit, because the less uniformity something is, the less chance you have of crack propagation. Meaning that if it's a nice perfect square edge, it makes it very easy for failure to occur all the way across. And so this case, by me sort of like manually doing it, I'm creating a lot of, lack of uniformity in my weld, so to speak, and therefore it keeps the cracks from propagating if it were to start to fail. So as you see, I have created a ridge line or a little bit of a weld. I might even just thicken this up just a little bit more because that's the zone of failure. So there we go. Fill that in just a wee bit. And there we go. So when it makes this, especially when the slicer gets into it, it's going to treat this very interestingly. It's going to actually create a lot of stiffness in this area because of all this up and down, this sort of organic nature to it. So imperfections, or things that aren't straightforward and straight edges, are actually a good thing. Now I'm going to flip it over, and I know that I need to deal with this on the back side too. And so I've got a couple of ways to do this. One is just to create ridges where it'll give just a little bit more strength. And by the way, just so you know, let me show you what I'm doing here. You see this all the time in plastic parts where they'll have like little fins, so to speak, and that's creating a strength factor right at those fins. That's what I'm going to try to accomplish right here. May not be perfect just yet. Let's see what we got. And I'm just going to let it get in the middle and kind of thicken up. And then maybe put another one right here, and then focus it right there. And then maybe one more here. Just providing just a little bit more resistance. Trying to not get too deep into this, because if I get too far into it, I'll interfere with the actual bracket attaching. So I don't want to do too much of that. So I may just keep it right here. And I can always, if I get into a physical situation where it is too far, I can always come in and grind it off. And one other little trick I'm going to probably do, again looking at where the joint is, right here is the target zone. I'm going to get in maybe a little bit more strength and create a very well-defined ridge. Maybe thickening it up right there. And with Mesh Mixer, you're going to find that its desire to jump a lot of times in terms of inflation is somewhat interesting and problematic. Because those ridges, even though they kind of look like weird growths on the side of the object, they actually provide a lot of strength. That was a little too much there. I'm going to dial that back just a hair. Sometimes I found that the flick with your left mouse click as you're doing this is better with Mesh Mixer. So, although it looks weird, maybe straighten that out just a little bit more there. It looks weird. These little ridges are actually going to provide a good amount of strength improvement overall on the part. And just go ahead and do this one too since I'm here. Thicken that up. Because I know where the stress is going to be, that's ideal for us. So now if you've gone through the project and actually modeled one of these type of creations with us, feel free to do that. But it's also just a quick little 10-minute tutorial on how you can really strengthen parts with this whole, like mesh welding feature, making them, look even more organic, and also making your parts stronger once they're printed with little amount of material wasted. You're really getting the material right where it needs to be. So there we go. Hopefully that gave you some good little tips. We'll see you next time.